I just finished converting an app from an imperative style of Angular to a completely reactive style of Angular. So I want to try to distill the process I followed into this video. I also wrote an article. It's not quite published yet, but I'll basically be following along that article. I'll put a link in the description as soon as it's published. But yeah, let's look at the app I converted first. Here it is. It's just a movies app. It's written in Spanish apparently, but so it's got this carousel. These are the same videos, but it's just cycling through them, and you can manually navigate through them, and it will just pause when you do that. You can also search for movies. So Spider-Man has been my go-to, and the server's not running. So let me go start that. All right, there it goes, and let's refresh. And oh no, where are they? Oh, Spider-Nam. That, yeah, I don't know. I don't think that's a real movie. So, Spider-Man. There, wow, okay. All right, there it goes. So that works. So that's the search page. You can click on the movie detail. You can go back. That is the same behavior as before, but what is different is this works. You can refresh on the search page. That's a bug that I accidentally fixed by refactoring to reactivity. So that's pretty cool. Okay, so like I was saying, in this video, I want to distill the process I followed and kind of go in some detail into what I actually did to change things over time. But the first part of the video is going to be more like a summary, and then the second part is going to be a detailed look into the diagrams that I created, showing how the code evolved, and showing the code along with it. So I've never done this before, but I think it might be interesting, so I'm going to try it. So from the first article I wrote on in this series, I showed the callback function that I started with, the event handler I started with. It was changing 3 pieces of state. So I refactored that to this. I have an observable of the URL, and I'm detecting when the people navigate home, and then I'm causing the other 2 state changes when that navigation happens. So it used to be 3 state changes all at the same time. Now it's 1 state change first, and then these 2 react to this state change. All right. So I'll show the diagram on all this later, but it's just kind of an overview. That's what I did. Something I missed from the first article is that NGRX Component Store actually has the way to react to observables. So you can call an updater and hand it an observable, and it will react whenever this emits. So I could have just done that instead of this. I kind of liked this because it passes subscriptions to the inner observable here to the state. It passes subscriptions from the state, from the store, to these observables in here. So that's kind of I think it's kind of important, but it is relatively minor. All right. So, but this URL code that I wrote, this was maybe the first hint that it was going to be temporary, because you don't normally write code that reacts to URLs. Usually you just do something inside the route. So this global store that has these 2 pieces of state that I'm changing, actually what probably needs to happen is that needs to happen inside the route instead. But that's just a hint. There's other code that's changing this state, so I can't really change it yet. So that's what I'm talking about. The flag here is what's being changed. It's being changed by 2 different things. I got rid of this one. Yeah, this one over here, the one on the left. And the 3 state changes that were happening, that's now gone. But there's still another thing updating it. So I had to keep it in the store so it could be accessed still. So that other event handler is actually where I went next. I went over to the other component that was that had an event handler that was calling that change function for the flag state in the global store, and I got rid of that next. So this is basically the process that I like so far. It's the best one, I think. It's to start with some event handler and then look at one of the pieces, maybe the simplest piece of state that it's changing. And after you have all of the state that's being changed by that event handler, once you have it all reacting on its own as much downstream as possible, that's when you want to look at the simplest state and see if there's anything else changing it, and then go get rid of those event handlers. So then eventually you'll have a piece of state that's completely reactive and not being imperatively controlled anywhere. So that's what I did. And eventually this, I wrote this down as a process, 7 steps. Yeah. So first, find an event handler. This is the overall process to convert to reactivity. You first find an event handler, and then you delete it, and then you, of course, take note of all the things that's changing, and then try to have that event make a single state change instead. So I had 2 options, and I actually changed my mind about these in the middle. Let me find. Hang on. Right, so this was it. This was the first event handler. So I got rid of this. So now there are 2 options. One is to create my own single point that it can push changes to, like a subject that the template can just put one change to, and then have everything react to that. But then I realized that these 2 things could actually react to the URL. So I just made it into router link, which changed the URL, and then these things could react to that change. That's the code you already saw. Okay, next is to, so get the next state changes to react to that immediate single change. That's what I did with the 2 states reacting to the URL. And then of all those state changes, find the state with the fewest remaining event handlers changing it and move to one of them and repeat steps 2 through 4. And so it will involve other state changes possibly, but just come back to the original state you're focusing on, because your goal is to get to the first state or feature that is completely reactive. And because you want to get to the point where things simplify as early as possible, because there's going to be like a chaotic point in the middle where you have one imperative. That's the imperative paradigm. You have one paradigm that's changing state, that's imperative, and then you have a reactive paradigm, and then you have like this boundary between them that complicates things. So what you want to do is try to convert a single feature to complete reactivity as soon as possible. What happened in this code base is things seem to be getting a little simpler, but there were kind of a few weird things like that state change reacting to the URL, that thing. And then it kind of hit a turning point in the middle of my conversion effort, and everything kind of condensed and simplified, and it was awesome. Halfway through, I thought that maybe at the end there would be more code than before, but it ended up being 32% less code. So the goal is to get to simplification as fast as possible. All right, so once all of a state's old handlers are gone, move it as close as possible to the features that use it. So what I noticed after I got rid of both of the event handlers that were changing the flag state, that flag state no longer needed to be in the store because nothing was changing it that needed access to the store anymore, or nothing that needed access to the store was changing anymore. That's what I meant. So I could then move that flag state to local state basically. So that was pretty awesome. That's where a lot of the simplification started happening. So just repeat these steps for all the features, and you want to try to go downstream first. So remove an event handler, get all of its immediate state changes reactive, pick one of those states to have completely reactive so nothing is changing it, and then find all the features that are using it and try to put it at the lowest level that all those features can access. That simplifies it because it keeps it from kind of polluting the global space. So you don't when you're looking at things that are really global, you don't have to look at that thing that's actually kind of local. It's better grouping of concerns. And again, I'm going to be going over some of these details in a really interesting way, I hope. I can't wait for that part. Okay, so next thing we need to do is wrap imperative APIs, because there's so many imperative APIs. It's awkward and it makes it difficult. It basically makes it impossible to write reactive code, because you're having to do these manual subscriptions. You're having to call these imperative APIs, and it interrupts your reactive data stream. So what you want to do is create declarative APIs. I always forget that. You want to create declarative APIs that you can plug your observables into. All right, it makes things so much nicer. I wish I had done this a long time ago. I thought really hard about this, and I eventually came to the conclusion that this was okay. It reminds me of dialogues where you're controlling something global inside of a local template. And it's similar to router links, actually. It's just, instead of like an implicit click handler, it's got this explicit URL declaration, basically. So this was awesome. And then I made a Sweet Alerts wrapper that kind of does the same thing, but it wraps an imperative API for opening alerts. All right. There was a third API I haven't talked about yet. Those were from previous articles, the last two. But this one is something that I did. It was kind of like local state. But it was a carousel. You know, the carousel here? This thing was being controlled imperatively. The code was grabbing the reference of the component, the reference to the component from the template. And then when they hit pause, it was directly commanding the carousel to stop or to resume. So this was like, this is kind of annoying. I realized that I could just change the interval it was looping by instead. So the carousel in the template, it was actually, let me show you, it takes an interval property. So I just increased the interval to, I tried infinity first, didn't work. So this is good enough. This is totally good enough. If I could pass an observable to the carousel, then I could pass the never observable. But instead I have to pass an actual time, so that's going to be 99999. I kind of got this idea from Josh Maroney. That was his original carousel implementation, was in a recent video he did. But I think it's great. And this is actually stated app syntax. This is called an adapter. It just defines some common state management patterns, pure functions that are relevant to a specific piece of state. So like Boolean, it's for a Boolean. And I have a Boolean adapter which comes with some default stuff like set false and set true. But I added a selector onto it so I could look at the state of the paused adapter. And if it's paused, then return a super long time. If it's not, return the regular interval that was configured already. Okay, this isn't actual state yet. You have to actually initialize it into a store. And so this is the path that's going to show up in Redux DevTools. This is initial state, and this is the adapter that handles the state. So it defines the logic that you use to manage the state. So here's where you actually define the state, like how it behaves over time. This is declarative. Every time an arrow is clicked, you set pause to false. Wait, what? Oh, that's right. That's an arrow. That's an arrow click. I just used the same naming the guy had. I actually didn't know what this was referring to. I'm just guessing. So I think this is a keyboard arrow. And then indicator is, I guess it's one of the arrows that you can click on. So let's try the keyboard arrow and just see what happens. So maybe that just never worked. Okay, so actually what you need to do is click on it, and then you can use the arrows, and maybe it resumes because it has set false on it. Well, I can look at Redux DevTools and see, just make sure. Let's see, diff paused false. So that looks good. Is this? Yeah, I don't really understand the behavior super well, but I went over to the old code and ran the server, and it behaves the same actually. So, yeah, I think some of the behavior is implicit to the carousel itself. So, yeah. Okay, so actually, when you click on one of these, that is when like the indicator event goes off. So anyway, this is detail. I can go over this later. Yeah, I found the code though that it's set to pause on indicator false. So I'm going to try true just so we can see that other state change real quick. And it probably already refreshed. So yep, look at that. Set pause from false to true. Okay. All right. Sorry. I'm ready to move past this. I just needed an answer. Okay, so right. Set false is caused by when those arrows are clicked, or probably not clicked. I don't remember. Doesn't matter. Anyway, these reactions are caused by these observables. All right. So this is super nice. I wish I'd done this a long time ago. So here's my message for everybody. Wrap all the APIs in declarative APIs. Okay. Your life can be so much easier. Look how nice this is. If you have an observable of something, you can just plug it in and it works. That's so nice. Yeah. Look at how dialogues are open in all the other libraries. It's not declarative in Angular. Why not? It's because Angular has carried a lot of traditions from old AngularJS, but they're just traditions, and it's so nice to have declarative APIs. So, yeah, wrap all the APIs in declarative APIs. All right. So, it's now time to look at the diagrams and walk through each stage in the process and how it got so simple. This is awesome. And here's a placeholder for a video that will soon be this video that I'm recording right now. All right. And make sure you give Stated Apt a look if you haven't. Okay, so diagrams. Here's what I made. Look at all this. Can you believe I did this? It actually wasn't that bad. What I did was, actually, it kind of was a lot of work, but most of the work was creating this. And then I created these things incrementally. And then I created this. This was fun to create because I couldn't believe how simple it became. And then I created like the intermediate steps by just incrementally moving from one to the next and looking at the commit and the code, how the code changed. Okay, so we don't need to do an overview of each diagram. Instead, I'm just going to show you the changes between each one. Okay, so first one is that first event handler that I changed. We already looked at that today in this overview, but I'm going to look at it again. All right, this was the first event handler I did. So navigate back. It's just basically called from a back button in the template. So right where's the button? Right here. Here's the button. Right, that's why. So I changed it to router link, but it used to be click, navigate back. All right, so that is what I deleted. So there was 3 pieces of state they need to change, and you can ignore this. This will always be truthy, so that wasn't doing anything. Also, I think now that I understand what flag is, this I don't think is actually what the developer intended on doing. Okay, I get it now. He didn't want these to happen unless this was true because these didn't need to happen, but it actually is harmless to have these happen. So it's equivalent to just having the 3 state changes. This, delete movies, that's actually search results, and then flag, and then navigate. All right. So I deleted that event handler and I moved it to the store. So this URL here, this is just describing an observable that emits well, it doesn't matter what it emits. It just emits when the URL that's being navigated to is the home route. And then I plugged it in here, both of these places, so that these two state changes happen when that URL navigates. Okay, so let's look at that diagram. So this is the event handler up here. Inside info movie, the navigate event handler, it was doing three things. Deleting, oops. That's actually deleting search results. It was just named movies, okay? Like delete movies. That was probably not a good name. It's actually deleting search results, okay? So that's actually what it was doing. All right, so it's deleting search results, setting the flag. Wait, did I just have both of these go to the same? No, that one's going to flag. Okay, they're getting overlapping too much. So anyway, so here's what it looks like now. That event handler's gone. So what do these two things do? Okay, this is, okay, hang on, I'm going to change this. All right, there, all better. I changed it to an orange arrow. Okay, so here's what's happening. The URL is now, well, I didn't include any arrow for the router link that this changed to because it's not really, I mean, it's completely internal to the router link directive. So it's not really any data flow concern we need to be worried about, but that's changing URL. And then these two pieces of state can be downstream from the URL itself. So I have this logic in the store. That's what that observable is. And this two state changes it's being plugged into. And the difference between the white arrows and the colored arrows is that the colored arrows are, it's kind of an indication that this cause and effect arrow relationship is defined by the downstream state. Whereas with the white arrows, these are indications that it's being controlled externally. Okay, so the more colored arrows, the better. So the flag state now just reacts to the URL, but it's also being changed by this event handler. So I looked around the code base, and this is annoying to do, but you can do find all references to the state change functions and see which of these two states has the fewest other state changes being given to it or commanded, inflicted upon it. I don't know. I struggle with words. Okay, so the flag state is the one with only one other event handler. So that's where I went next. This is the one that I tackled next. So I showed these diagrams before, but this is how it looks now with that event handler I just deleted. So the router link changes the home URL, and then these two things in the store react to it. And this little rectangle, that represents the logic that it requires. Whereas before it was up here in the callback function or the event handler, that logic was there. Now it's located in the store itself. And so this shouldn't be there anymore. That should be moved over there. So I need to make that change real quick. Hang on. And there it is. How cool. Okay. So now I'm going to attack this event handler. And what it is now is this. And so there's a lot of stuff happening in here. It's not all happening at the same time. So I used to say that reactive code was organized by the relevant state it's controlling, and imperative code is organized by what time it executes. But that's not even true, because you can have a subscribe, you can have async stuff within an imperative event handler. So yeah, reactive code is awesome. Okay, so with this, remember, like the goal was to make a single change and then per event, and then have everything be downstream that can be downstream. So what I changed it to, this was my first idea. I'll make a subject, and it can change a bunch of things, but there's like this intermediate observable for search results. And then in the store, these three states will react, and the URL will also react to those results. And anyway, so I thought it was going to be like this, but it eventually simplified to this. So the template just makes a single call to search $.next, And then I have that router, the app navigate, the router navigate wrapper component. So that's in the template, and that takes in the URL. So let's look at that code real quick. Here it is. So you can see on the left, this giant callback function here. And then on the right, it's just the search subject. The template is, that's the only thing the template is concerned with. It's just pushing to this. And then you have two things that are downstream from it. And first we'll talk about is a URL. And so this takes the search, makes sure it's valid, and then it creates the URL that should be the next URL, or it will be the current URL once this emits. And here's that being used in the template. Just URL equals URL async. And this will just make sure that, and I like putting this at the very top of the component because that kind of mirrors where it is in the UI. You know, the search bar or the whatever it's called in the browser, it's at the top. So this just says that the URL, the current URL of the app should be this, like according to this, it should react to this observable. This observable describes it. It is this observable. If you emit null, which the async pipe does initially, it won't do anything. Empty string won't do anything. So yeah. So that describes the URL and that wrapper component I made. It's pretty simple source code. I could show it to you, but it actually doesn't matter. You can look at the article in the description, and if you, in the article, I should have a link to the repository, and you can see it's called just the navigate component. All right. Okay, so the next part is having the toast react to the search when it's invalid. Okay, but whenever you go from an imperative thing to a declarative thing, you have to create state that will be banished, because before we were just calling this swal method, just saying, hey, do your thing. Like there's no return value of this. It's just calling out to nothing to go and open this dialog. So I had to manage state now. And so what this looks like now is in the template, I have, let's see, I now have an actual piece of state that describes the state of the dialog. And so we actually have to manage state now. And then when we close or when it emits a close event, then we go to that state and tell it to change to false. And so that state is always representative of the actual state of the dialog in the UI. All right, so first, here's the subject, the search subject, and then I'm mapping off of that. And when it's invalid, this emits as this type of source. Search is invalid. And then here I create a store, a stated app store. The initial state is false. It uses the Boolean adapter, just like the carousel I talked about earlier. And then it is controlled by this source that we just defined. So when it's invalid, it emits. So if it's invalid, this is going to emit true. All right. When it's valid, it's going to emit false. So this always represents the state of the application. We can see that in Redux DevTools. So we hit enter and it's invalid. And you see Redux DevTools, this got set. So invalid alert open got set from false to true. And that is the state of the app. You close it and the state of the app becomes that the invalid alert open is false. Okay, so that's now managed as state. And that was the first thing this app to show up in Redux DevTools, which was pretty great. Okay, so that's how that's working now. But I also had to change the store to have 3 pieces of state that used to be controlled over here imperatively. Now that has to react. So it turns out it can also react to the URL. So a lot of similar code, just like last time. Let's look at that. So before I had this URL, this one observable that was looking at the navigation end and filtering and looking specifically for navigating to the home component. But now something else needed to react to the URL, so I split off the part that represents the URL itself. So that is now just called URL after nav. And now the one from before just chains off of that, and then a new one, well, search route is a new one that chains off of that, and it's filtering by whether it's on the, well, what if the URL starts with the /search string. Okay, now we look at this results observable. This is going to use this is a little weird, but inside a service, inside a global store, you don't really have access to the query parameters, right? Or the full tree of the URL. So I had to basically parse the URL myself, but it's a really simple app, so this didn't matter. It was easy. I'm not sure how you do this in another app, but I kind of knew this was going to be temporary code anyway, because it's like what I was talking about earlier, that the fact that it's reacting to the URL means it should probably be inside of a route. Okay, so, but this was just fine. So I'm just taking the string that happens after search. So the search term will appear after this, and that's what gets put in there. And then I call the API with that. And then I do that mapping logic right after that. So remember that the way I had the diagram, this is probably should be a rectangle here, but regardless, the rectangle represents the logic for controlling what state's going to be like. And now that is here in the store instead of up here. So this search results observable right here, that's what that logic is. That has now been moved to the store. So yeah, it's better there, because you're looking at like, okay, when we save search, it's going to become the search results. And you can click to the definition. Instead of finding all references, you can just look at what is here. And you'll see that it's defined as something that hits the API and then kind of changes the shape of the data to something the store wants. This app is using a bunch of any's. I just kept that from before, but whatever. Okay, so that's that logic. And now that's all here in the store, and we have 3 state changes now that are all reacting to that. All right, so that's pretty awesome. So let's look at the diagram again. What should we do next? Well, flag now is reacting to 2 things. If we look where it's being used in the header component and in the search results. What component is this? The movies list component. Okay. Oops, get out of there. Okay. So now we get to look at the component structure. I was trying to figure out how it was being used. It turns out that flag just meant, we are looking at search results. So it just literally means we are on the search page. So it's actually a completely redundant state. So it's duplicate state. So everything that was downstream from flag, that was using flag, could actually just be downstream from the route itself. So this diagram here, if we removed this piece of state, then we could just have these components react to the URL. But then I also noticed that these components right here were acting in a weird way, because movies list, here it's determining what route we're on. And I'm not used to like a list component knowing about the route and stuff like that. So what it's doing is it's choosing between selecting from regular movies or search result movies. So that's kind of weird. Usually it's not supposed to be a smart component like that. So this is how it was. So we've got movies state, That's being used in the carousel component and in the movies list component. And then we have a like the header. That's actually the search term. It's being used in the search component, and the results component is a child of the search component, and the results component has movies list as a child as well. So that's being passed all the way down. Movies list is taking 3 pieces of state in, and it could just be taking in a component input of movies. So instead of movies being passed to the carousel, we could have movies and the movies list. We could have movies passed to the carousel and then have the carousel just give them directly to movies list. So here I added that input to the carousel's template. Now it's just giving it the same movies it has. And then flag is redundant state, so that will just go away. And then search results can just be passed directly to the results component. And then it can pass them on to movies list, just like the carousel component passed the regular movies. So movies list becomes a dumb component that doesn't know where its movies are coming from. It just shows them. And in this way, we get rid of flag. It's not needed, and it doesn't even need the URL to know which list to pull from. But this simplifies the data access, and it allows data to be used closer to the features. Okay, so this is how it looks now, with movies going to carousel, then movies list, header going to search, and then results, and then flag isn't even needed. Okay, now that flag isn't actually used, here's what the diagram looks like. Flag, oops, wait a sec. Oh, well, I should delete this arrow. Okay, so I still kind of had flag in the state, but I didn't need it. And as part of that process, I discovered that header could actually just be taken from the URL, the search term. If I put it in the URL, then the header component or the search component could just grab it from the URL, basically. Okay. And so I have 2 pieces of state now that no components are interested in. It's now completely represented as part of the URL. The fact that it's on the search page and the flag and the header being in the search in the URL as well. So, and the next step, I was able to remove those. So that was pretty exciting. But there's another thing. There's a problem, I think. Actually, no, there's no problem with that. I think this, where did I get the idea to, how did I work on the next thing? Because you've seen this other diagram here. Open movie details. This was in the movies list component as well. So this is the next callback function that I deleted. And instead of having it like here, instead of having the movies list open it by setting the selected movie and changing the URL, I had it change the URL with the movie ID in the URL, and I had selected movie be downstream from the URL now. So it listened to the URL, take the movie ID, and put it in the store. Okay. So let's look at that in a second. But I also got rid of the same type of callback function over in the carousel component. It was doing the same thing because both of them are showing the movies list, right? But the carousel, it has the movies list, and the movies list has its own way of opening movie details, but you can also click on a movie in the carousel itself. So these are kind of the same function. They could have been reused, but it doesn't matter. They both became router links. So here's how the movies list component changed. It just became a router link. Pretty simple. And let's look at how the store reacts to that now. Where is the store? I deleted the store. Right, I did everything all at once. So I don't have really code to show you for this intermediate step for this one. Because basically, if you look at what it is now, after the component refactoring, I just have the results component that is now accessing the results from the store. The header is getting it from the URL. The search component It has an ng on in it where it's like redirecting. Like this is all really low hanging fruit. So I just cleaned everything up. But the main thing to notice is that at least everything over here is done. It's all reactive. And all that we have now is extra state in the store that we don't need. Because look at this. The URL is being listened to by selected movie in the store. But where is this being used? Only in one place. So selected movie, let's look at the info movie component. The info movie component now just has, it's now just listening to the activated route. It's getting the ID from the route params and fetching the movie. This logic was already happening in here. It was just grabbing the selected movie. Well, not the route thing, but it was getting the movie and fetching movie details again. Because this movie came from the list, and apparently there's an endpoint specifically for movie detail for a single movie. So either way, you have to fetch this again. So you just grab the param. That's all you need to fetch is the ID of the movie. So that's how I did it. I passed the ID from the route param and then mapped it the same way it was being mapped before. So that was a big simplification. Now, instead of needing the store for selected movie, that could be just in the component itself. There's literally no reason not to do this. It is unidirectional. It is reactive. It is perfectly clean. Yeah, and there are other benefits. Like, instead of just having stale state in the store when we're just fetching it every time we get to the route anyway, now we have it cleared from the store. It's not in the store at all, but this observable will subscribe again and make another request every single time you visit the route. So it takes care of that side too, the refreshing side. So, okay, so that's nice and automatic. No more stale state in the store, and it's just its own thing. So it's reacting to the URL, and it's being a selected movie. All right. So what's next? Search results. It only has one component listening to now as well. So in the store, remember, I had that observable that was chaining off of the URL and getting the search term and fetching the movie results from the search. So let's look at what the results component is doing now. Results. Yeah. So it's just taking the query parameter from the URL and searching movies with it. Very, very simple. So it's just downstream from the URL. All right. So now that is how that looks. Okay. Now, let's do, so flag and header could just be deleted. Those are route data. That's just route data now. And let's see. So movies, the last one. That is only being used in the carousel component. So it was reacting to the URL. Remember, in that first get diff that you saw, it was chaining off, and I think it was watching for when the route hit the home page. I can't remember. Maybe it wasn't doing that. I don't remember. It had to have been because I have it chaining off of the URL here. So, okay. Anyway, but if you're at the home route, another way to react to being at the home route is to put the observable in the home route to define it there. So I could just move this movies observable over to the carousel component. But there's some other imperative stuff that's going on, which is why I've done this component last. Because we've got toggle pause, and I explained it earlier in this video, but what it was doing, let's look at that component now, carousel. Right, so we got toggle pause right here. is changing both the carousel and the paused Boolean. So the paused Boolean and the carousel, okay? But I realized that I could just have the paused Boolean be downstream from, so you can directly set it from the template. Where is that done in the template? Let's look at that. So let's see. Toggle pause, right. So you can directly toggle it from the template, and that was the same as before. Well, no, it was calling that method before. That's what it was doing. So before the template was just calling this method toggle paused, and now it's directly setting the Boolean and only the Boolean. So it's one minimal state change per event. Okay, and the other event that happens is a slide change. So the slide change splits into two other types of observables. Ugh, God, I can't even get it right after I try like the third time. Okay, observables, arrow and indicator. And I spent way too long already talking about that earlier, so I'm not going to do that again. But both of those feed into the paused state. So now paused is a state adapt store that reacts to observables. So this right here is these two arrows controlling paused. Okay? And kind of like I already explained, the white arrow means it's being controlled externally. With Angular, and I think most frameworks, Cycle.js almost being the only exception, is being as close as possible to an exception. Every arrow from the HTML has to make one imperative change, minimum. So we want to minimize that to one imperative change. And so grade means this observable here defines itself with this arrow. White arrow means the thing below is being defined by the arrow from above. So paused is being controlled externally by the HTML still. That's imperative, and I don't love that, but I can't see a way around it. And so, but the colored arrows means it's paused itself, where paused is declared. This is where this state is declared. Like here's the initial state, here are the patterns that it will use to change itself, and here is what it has declared itself as being changed by. So that's why it's green. It owns its state changes that come from these observables. And this adapter defines the way that the template controls it. So it gives it the toggle state change that it can call from the template. Okay. But now the carousel can be reactive to this. So instead of having these two parallel states, I figured out that the carousel cycling state can be downstream from paused, because that's what paused really means. If paused is set to true, it should be able to, the code should be able to be organized in a way where the paused, like whether the carousel is running or not, is determined by that paused state directly. So, okay, so look at this now. This is the interval property of carousel, and it's dynamic. Okay, so this is what I used to control its paused state. So it's downstream from paused, and part of this paused store is an observable called interval, and it is defined by the adapter, which we can click to definition and see. And it's just taking the pause state and setting it to a really high number. So basically the carousel will take forever to move. So it's the same as being paused, basically. Unless you're going to sit and look at the carousel for, maybe I should increase that number. That's only like 1,000 seconds. It doesn't matter. Yeah, feel free to like stare at a carousel for, look, it's close enough. I'm totally fine with that. Infinity doesn't work. I wish it did, but it doesn't. So anyway, but this is the way to make to get rid of the imperative API where carousel was being controlled by this event handler. And so now it's declarative. It responds to the paused state. So now anything now that can possibly put the carousel into a pause state, automatically the carousel will react to that appropriately. All right. And I think that's the last state change we need to talk about. So there's kind of a big step from this one to this one, but most of it was just realizing that these last couple of event handlers are really simple, and then all this state in the store didn't need to be in the store. So if we go back to this article that I've written, find the state with the fewest remaining event handlers changing it, move to one of them, and repeat steps 2 through 4. So you're just taking each state and deleting everything that's controlling it externally and having it control itself internally as much as possible. Once that piece of state is completely self-determining, you can move it anywhere you want to. It doesn't need to be available for the entire app to be able to control it. So now it can be moved to where its consumers are. And that moves it out of the global store. And then, step 6, move it as close as possible to the features that use it. And then step 7, repeat that for all of it. For all the state that has imperative handlers, just pick one. And actually, this is talking about like downstream stuff actually. But this is how you convert a piece of state to be completely reactive and then clean up after. So this is the cleanup part, and this is kind of the cleanup part too. It's just like kind of moving further downstream and simplifying things further. Okay, so this is the process to follow, and then I guess you just repeat. Maybe I could put a step 8 in there, but it already has so many steps. Yeah, this is good enough. So that's the process you follow to take a feature that has imperative wiring and make it reactive, little by little, and going from the events down to the features. And then the final result is you started with this, and now it's this. I got rid of 2 bugs during this process. One was searching and being on this page and refreshing. The old app would kick you out because it wasn't reacting to the URL inside this feature, or even the global store, because this was working even when I had it in the global store still. It was just reacting to the URL, so it was working. Okay, and the other one was movie detail. The ID didn't used to be in the URL, so it wasn't reacting to the URL. And so it also kick you out. Actually, I think you'd just get stuck on this. I don't remember what would happen. A bug. Something stupid. So isn't that nice? 2 bugs that I accidentally fixed. I wasn't aware of them until I worked on this. And then, so that's pretty nice. 2 bugs fixed. A lot simpler data flow. And now it's completely reactive. And the total code change is 32% less code. So this was pretty satisfying. That was awesome. I like reactive code. And doing this inspired me to write another article. It's called 5 Reasons to Avoid Imperative State. First one, inconsistent state. That's what the 2 bugs were. The second thing, state elevation. So you can't have things local if, I thought I was on this diagram. Okay, you can't have state local and co-located with the features as much as possible if it needs to be up here so that all the other features can control it. So that's called state elevation is what I called it. It was state that could have just been in the feature, but since we're thinking imperatively, we need an event handler over here to be able to access this. So it can't be in this component anymore. It's got to being a global store. So that's the second problem. The third one is, look at this. This was a ball of spaghetti, and this is cleanly separated by the feature. So it's vertical separation. So things are co-located by feature. And so the code splitting can now work. It can now be, each feature can be siloed as its own chunk. So even here, like this URL, I have it drawn like this, but I could have drawn a URL there, have that down, URL here, down, URL here, down, URL here, down. Not in the middle one, but anyway. And the point would be there would be no lines going between features. That's how this app could have been written from the beginning. This could have been this from the beginning with complete vertical separation. All right. So that's the third thing, being able to lazy load better. And the fourth thing is the complexity, because this is just complex. Figuring out what determines what movies is. It's being set. Is only being set in one component, so that's not complicated. But search results, it's being cleared and then set again. And this color should change then too, huh? And then being set over here. Yeah. So it's just being controlled from everywhere. And in order to figure out everything that's happening to it, you have to click to definition and see everything. Okay, and then the fifth issue is one that I kind of ranted about in the last video, and I was just naming, because look at this. Like, navigate back makes sense, but it doesn't describe everything that's happening. On submit, okay, it's a thing that happens when you submit. It doesn't describe what it does. And on init describes something that happens at a time, not what the function does. Open movie details, that is probably the best name, and that's because it's the least imperative function. It's doing only two things. Except it also kind of is hiding a detail. So basically, the only thing you're going to find with event handlers is either you're ignoring something that it does when you name it, or you're naming it by when it's being called instead of by what it's doing. So that's the fifth reason to avoid imperative code. You have to come up with really annoying function names that don't really adhere to clean code principles. So that article is next, but this was so satisfying to work on. I've never dived this deep into the data flow and really drawn it out and looked at the big picture all at once, but it makes total sense, and I love watching it clean up at each step and realizing that this is the exact same behavior, actually even more capable and more correct than this. This is more work to write from the beginning. So if you have the right mindset, you could write code like this from the beginning. And I'm sure you would be at least twice as productive if you adopted the reactive mindset. So this is why I'm passionate about this, because it's a lot easier to write reactive code once you have the mindset that everything should control itself and define what it is and what it reacts to. So I'm not getting bored of talking about reactivity nonstop. And right now, this is kind of focused on Angular, kind of a little general for this one, but it was mostly, it's an Angular app. But I'm going to visit every major framework except possibly Vue, because Vue is confusing to me. It's got too much stuff. It's changed too much over the years. I don't know. It's its own thing. Maybe I'll look at it. I don't know. But I'm going to visit, let's see. So I've been doing Angular. I'm going to do another couple projects. I don't know if I'm going to make videos about it or not, but I'm going to do a couple more. I'm going to release Stated App 1.0. Then I'm going to go look at React. And React is going to be really fun because there's so much going on in the React community. So many libraries, so many apps to choose from and to refactor. And the level of confidence in their enlightenment is so high that I just can't wait to thoroughly describe what's wrong with it. It's going to be so fun. React is an MVC framework. And just saying that will push a lot of people's buttons, which is just so fun. So yeah, I'm going to visit a couple of state management libraries and look at common ways of managing state in React and analyze how reactive they are and refactor them to more reactivity. And then I'll move to Svelte. That's going to be fun because it's going to be nice and easy. And there's a little bit of that same React type stuff going on where Svelte people are like, well, this is actually reactive. Like this isn't just rerunning everything. This is actual reactivity. The syntax is just about as reactive as React because actually synchronous reactivity with React, everything just renders. So everything reacts. So the mechanism is what's different. That Svelte is more performant. That's what's different. So anyway, then I'll go over to Solid.js, and that will be fun for the same reason that Svelte is, because everyone like React probably, I would say in Angular, 3/4. I'd say it's like 3/4 reactive, because change detection is kind of reactive, but ArcGIS is so popular in Angular but it's not totally used because like you saw with this app, this isn't reactive at all. Like, well, it kind of is because it's using observables from here to here. That's synchronous reactivity. So even in Angular, people struggle with the async part of reactivity, and that's kind of the important part. Well, it's all important. All reactivity is nice. But yeah, so it's rare. And yet we've seen RX Angular grow in popularity, and that does let state be reactive. And NGRX component store, I don't feel bad at all about saying that initially, oh, it can't react to observables, because they do not emphasize it at all. Look at this. Updater method. Okay, this is cool. How do we use it? Well, we call updater, and oh look, we can call add movie. How nice is that? That the example they give is imperative. That sucks in my opinion. Or could take an observable. The most important thing on this page, and I missed it. So that's why I don't feel bad about missing it, because look at this. Imperative, update, set, patch. Those are all imperative names. This is how to make reactive state. And this makes it kind of like RX Angular. So that's the most important part in my opinion. And it bugs me that it's just basically like a tiny mention. So anyway, but I'm happy about RX Angular that it's gaining popularity, and hopefully eventually Stated App does too. But what I want is for people to code reactively, and Stated App is my take on what the nicest way to do it would look like. So this is like the home page of Stated App documentation. You can do really complex things in very short code snippets, and then like it's totally reactive, as reactive as possible, because you still have to call .next from the template like and everything. But yeah, okay. Right, so I'd say Angular is like 3/4 reactive. It's getting more reactive, and all of web development is. React has been getting more reactive. I would have said a while ago that it was only half reactive, because it's got that derived state thing that's synchronous, that's totally easy. You don't even have to think about it. You have a component, and you have const x equals 1, const y equals 2 times x. That value y will always be 2 times x. That's reactive. So it's basically reactive. But then for async reactivity, you have React hooks, and what's becoming more popular is React query or TanStack query. That's async reactivity for data fetching. And that's pretty awesome. But I'd put it at probably 3/4 reactivity as well, because it's still like most people still don't really use React hooks as thoroughly as they should. And plus, you have to invent a bunch of your own utilities if you want to do all the async patterns reactively. So 3/4 probably. Svelte is probably half reactive, but derived stores, people talk about derived stores. I've seen videos about that, or heard of them, or saw thumbnails of them. I'm going to dive into Svelte and really judge how reactive it is. I'm just going to look at random projects in GitHub like I've been doing and figure it out. I bet it's probably like 2/3 reactive, probably just a little above half as far as syntax goes. And then solid.js, I bet it's around the same. So it's going to be fun talking about all these things, and I'm really not getting tired of it. I'm enjoying it thoroughly. My understanding is advancing as well. And so this has been really fun. And yeah, I don't know if I'm going to make a detailed diagram like this again. Maybe I will. I got faster at it as I was doing it, so maybe I will. But anyway, if you're interested in this kind of stuff, that's kind of what this channel is about. That's what I do, basically, is try to push towards more reactivity, because that's the main area of improvement, I think, in web development is reactivity. So that's what I care about. I'm interested in solid. Like half of my subscribers came from my video about solid and quick. But what I really care about, I did a lot of videos about ArcsJS and quick, and that's what I care about is reactivity. So if there's a new framework, I love it and I want to get to better frameworks. But the point is, how can I make sure that I get it out there as much as possible that reactivity is the best way to organize code in any framework? So that's what I'm focused on, reactivity in all the frameworks. So yeah. All right. Well, that wasn't too long, but anyway, thanks for watching, and let me know if you know of any interesting apps that you'd like to see converted to a more reactive data flow, or if you have any questions about specific APIs and how they could be wrapped, because that would be really interesting to look at. I've only scratched the surface on the APIs that are imperative in Angular and how to deal with them. So, all right. Thanks for watching. See ya.